Hello friends, this is part 5 of 4th semester mathematical physics paper solution, paper c-8 of 2023, physics honors, Dibrugarh University. Before we start, please subscribe the channel, also share with your friends, inspire me to create new contents for you, help me to grow my channel. Also hit the bell icon so that you get notified when new video will be uploaded, right? So now you see we have already solved up to question number 5. Today we're going to start with question number 6. So that is the last question of this paper. So here is the question number 6. There are 3 questions. So here we need to write short notes on 3 topics. We need to write short notes on any 2 topics out of this 3, but I'm going to show you all the 3. So first, singularities of complex function. So let me write a short notes on this topic. So 6a, so here we need to write short notes on singularities of a complex function. So what do you mean by singularity? So a point, suppose z is equal to a, is said to be a singularity of a complex function f of z if f of z, if this function f of z is not analytic at that point, right? So this is the definition of singularity, right? So now we're going to discuss about the type of singularity. Okay, so what are the different types? Okay, so we can classify singularities into 2 different types. Okay, types of singularities. So what are the 2 types? So let me write here. So first one is isolated singularity. Number 1, isolated singularity, and number 2, non-isolated singularity. Right. So now what is isolated singularity? Right. Now let us discuss about isolated singularity. Okay. If you see z is equal to a is a singularity of f of z and if there is no other singularity within a small circle, within a small circle surrounding the point z is equal to a, then this point z is equal to a is said to be isolated singularity okay of the function f of z of f of z. Otherwise it is called non-isolated singularity. Right. So now you see, again, this isolated singularity, it can be classified into three different types, right? Types of isolated singularities. First one is removable isolated singularity. Number 2 is pole, and number 3 is called essential singularity. Right. Now let us discuss about removable singularity. So here you see, according to Lorentz series, this function we can expand this way, that summation n is equal to 0 to infinity a n z minus z naught to the power n plus n is equal to 1 to infinity bn by z minus z naught, right, to the power n. This is nothing but Lorentz series. Right. So here you see, if limit f of z tends to a exists, and b1 is equal to b2 is equal to b3 is equal to dot 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 bn is equal to 0, right? That means here you see this part, in Lorentz series, if these parts become equal to 0 and this limit exists, then we can say that z is equal to a is then z is equal to a is removable singularity, right? Now let us discuss about pole, right? So if here you see, now if just let me do a correction here, just as I have written here z naught, so it's supposed to be z naught instead of a, I should write z naught. Okay, that should be z naught. Z is equal to z naught. And one more thing, here you see, if this part, this is called principal part, this part is called principal part, right? Here here you see, if so, let me take this one as a equation number 1, right? This is, let me take this expansion as equation number 1. You see, then we can write that let me clean this. If the number of terms of negative power in the expansion one, that means negative power means, here you see in this part, in the second part, if you write this term here, then it's gonna be z minus z naught whole to the power minus n, right? So there is negative power. So here, if it consists finite number of terms, right? If this if it consists finite number of terms, okay, if the number of negative power, number of terms of negative powers in the expansion is finite, that means after a certain value of n, the remaining coefficients becomes 0, right? It may happen sometimes the coefficients suppose bm for n is equal to m, then bm plus 1 dot dot dot, these terms, these coefficients become 0 after a certain number value of n, right? Then this expansion, sorry, let me take this as this is bm plus 1, then after that bm plus 2. So let us take that bm is not equal to 0. Bm is not equal to 0 after bm, that means after n is equal to, for the term n is equal to m, this term, the corresponding term is not 0, then after that remaining terms becomes 0. Suppose the value of bn becomes 0 after n is equal to m, then here you see, then z is equal to z naught is said to be a pole of order m, right? Then we're going to say this is a pole of order m, right? So now let us discuss about essential singularity. So now let me go to the next slide. Essential singularity. Right, so here you see, if in this function here you see, let me copy this expansion 1. So this is the expansion 1, and if the numbers, so let me copy this as well. So if the numbers in this expansion 1 is, if the number of terms in the expansion 1 is infinite, then z is equal to z naught is said to be an essential singularity, right? So this is all about singularities. So now let's move on to next question. Now let us discuss about Fourier transforms and its applications, right? As I have already explained in the course that made on this topic, Fourier transforms, so I'm not going to explain each and everything. So I'm going to give you the definitions here. So here is the definition, the infinite Fourier transform. So we're going to get Fourier cos transformation and sine transformation as well. Let me give you that as well. So here you see, so Fourier sine transformation and definition of Fourier cosine transformation, and take the screenshot. Okay, so now let me tell you the application. So this transformation, so these transforms are used for the solution of a differential equation, solution of differential equations. Differential equations depends on the nature of the boundary conditions okay, and boundary conditions of the equation. And the facility with which the transform suppose f of s can be converted to give f of x, right? So this is about the application. So now you see, let me go to the last question. So now last question, 6c, convolution theorem. I have already made a video on this topic. Link is in the description box. It is written this way: link question number 6c, and here you're gonna get the link. In this way, I've given in the description box. Just click the link and you're gonna get access to the video where I have discussed about convolution theorem, from which you can write the short notes. Okay, so thank you for watching. See you in the next video. Bye bye.